Right, we're now going to look at the factors affecting climate change, and we can split these into two. There are the external factors, which are the ones that are external of the atmosphere. So things basically that happen in space. And the internal factors, which are those, of course, therefore, within the atmosphere. Now, there's two external factors which we need to understand. First of all, there is solar output variation. And put into more simple terms, it basically means that the sun doesn't emit the same amount of solar output. It's not constant, it's not standard. There are differences. Now, a 1% change in output can lead to a plus or minus 1 degree Celsius change. Okay, now that might not sound a lot, but you're thinking about over the period of maybe 100 years, 150 years, 200 years, then these changes may well sort of add up, and then we may well be looking at things like 2 degrees, 3 degrees change, which actually can be a significant tipping point that will affect local climates. Something else in terms of solar output variation as well is a phenomena known as sunspot activity. On the surface of the sun, there are these things known as sunspots, and the basic rule of thumb is more sunspots are going to lead to a hotter climate. Conversely, of course, fewer sunspots lead to cooler periods. And a historical example of this, it was argued that there were fewer sunspots, is the Little Ice Age, which took place between approximately 1645 and 1715. And as I've mentioned in class, that was a period of time in the UK when the River Thames would actually freeze over in winter, and they would hold frost fairs upon it. Okay, the other external factor is to do with the orbit of the Earth and the angle of the tilt, angle of the axis of the Earth. Now, basically, the orbit of the Earth isn't, strictly speaking, circular. When it is a more circular just amend that mistake. When it's a more circular orbit, we tend to experience colder periods. When the orbit is more elliptical, then again we see that there are warmer periods. Notice here again how I'm just describing what's going on. I'm not necessarily explaining, because I don't think that that's actually what's been required. In terms of the tilt on the axis, the greater the tilt of the axis, we tend to get warmer summers and cooler winters. So currently the tilt of the axis is approximately 23.5 degrees from the perpendicular. If you're looking therefore at 24s, 25s, 26s, we could possibly, I think we'll probably get to maybe about 25 degree tilt. Then you would certainly be then looking at warmer summers and cooler winters, just greater variation. Okay, so they're the external factors. There's two of those, and it's worthwhile obviously knowing both of them, particularly if you've got a question that's asking you about external factors, plural, affecting climate change. In terms of the internal factors, there are 4 of them. First of all, volcanic activity. When a volcano erupts, it produces ash, which goes obviously up into the atmosphere. There is a global circulation of air, and that will circulate the ash globally. It doesn't just stay in the area at which it came out of the Earth. Now, because this ash is in the atmosphere, we've got particulate matter up there. It will lead then to increased reflection and refraction of the incoming solar radiation. It's being bounced off. It's not all hitting the Earth. Okay, and an example of this, again affecting the UK, 1816 is referred to as the year without a summer, and that was triggered by 1815, the eruption of the volcano Tambora. Okay, so that's volcanic activity. Of course, things like the recent Iceland volcano, that's not particularly happened because there wasn't a huge amount of ash that's been ejected out into the atmosphere. You're looking at huge volumes of ash in order to bring temperatures down. What's referred to as well in certain texts that you might see, or certain sources that you might see, as a volcanic winter. Right, next. Surface reflection, or the term I like to use for this is albedo. Okay, got to imagine here that we've got a cooler period, such as an ice age, where we've got large expanses of ice sheets and snow that are sat in situ on the ground. Okay, during these cooler periods, leading then to snow and ice, a large percentage of incoming solar radiation is reflected back into space. Now, in terms of snow and ice, you're looking at a rate of 90% of the incoming solar radiation is simply reflected back out into the atmosphere. The remaining 10% isn't going to cause a huge difference to the heating of the Earth's atmosphere, which is why places like Greenland and the ice caps, the Arctic and the Antarctic, we don't see huge amounts of snow melting, despite the fact that it's bright. When we see the sun, when we see photographs of it, sorry, it always looks bright and sunny. Right, third internal factor is the change in atmospheric gas proportions. As I'm sure you know from your science classes, the air that surrounds our atmosphere is not just oxygen. There's a cocktail of gases in there. One of those gases is carbon dioxide, and carbon dioxide is, of course, we can refer to as a greenhouse gas. What carbon dioxide actually does is that it absorbs heat. Now, obviously, we hear about greenhouse gases and we hear about them being a bad thing. Increased amount of carbon dioxide is leading to higher global average temperatures. However, without greenhouse gases, the average global temperature would actually be minus 15 degrees Celsius. It's currently, the average global temperature is 18 degrees, positive 18 degrees Celsius. So it would cause a massive reduction if we didn't have carbon dioxide. However, of course, increased CO2 concentrations will lead to increased global temperatures. As I'm sure you can remember, and you'll see from future revision videos, methane also is a very important greenhouse. It's important. It's another greenhouse gas, and it's more absorbent of heat than carbon dioxide is. Finally, last one is tectonic activity. And tectonic activity can affect atmospheric and ocean circulations of heat. For example, where we sit in the UK, we're at the end of a warm ocean current, the North Atlantic Drift or the Gulf Stream. If it wasn't for the North Atlantic Drift bringing warm waters up to the UK from the Gulf of Mexico, tropical area, then the seas around the UK would freeze. We're on the same lines of latitude as places like northern Canada, like Newfoundland, like Nova Scotia, and so on, where in the winter heavy snowfalls, lots of ice, and the seas actually do freeze around there. If there was a tectonic movement, and it would take a long time for this to happen, but if there was a tectonic movement that could actually block or divert that Gulf Stream, then the UK would end up being very negatively affected, to the tune of, an average temperature of about 15 to 20 degrees Celsius maybe at some point. Okay, so they are the 6 factors affecting climate change. In terms of exam technique, obviously you need to know internal and external. There might be a definition question asking you what is an external, what is a definition of external factors, which of course is the fact that external from outside of the atmosphere, internal from within the atmosphere. If it's a 2-mark question, you'll require some development, which could be to name the factors, and you may well also be asked to describe then the factors, which is what I've attempted to do with this video. Okay.